Let's turn our attention to multiplicity. And as I said at the end of the last video, if r is a zero of a polynomial and the exponent of the factor that produced the root, which is also another word for zero, is m, then we say that that zero r has a multiplicity of m. So if we go back to example 3b, we can see that the x plus 1 had an exponent of 2, so the root negative 1 has a multiplicity of 2. And the x minus 2 had an exponent of 3, so the root x equals 2 has a multiplicity of 3. So let's see if we can figure out the multiplicities here. But first, we want to find the x and the y-intercepts. So for x-intercepts, remember, we make y equal to 0. So we have negative x cubed times x minus 3 squared times x plus 2 equals 0. So using the zero product property, either negative x cubed equals 0, x minus 3 equals 0, or x plus 2 equals 0. So for the negative x cubed, we're just going to divide by negative 1, and we have x cubed equals 0, and then we take the cube root of both sides, and we're left with x equals 0. For x minus 3, we just add 3 to both sides, and that leaves us with x equals 3. And for x plus 2, we subtract 2 from both sides, which leaves us with x equals negative 2. To find the y-intercept, we just plug 0 in for x. So we're essentially finding f of 0, which means negative 0 cubed times 0 minus 3 squared times 0 plus 2. So that's 0 times negative 3 squared times 2, which is just 0. So now let's list each x-intercept and determine its multiplicity. So I'm going to put the factors here, and then we'll put the x-intercept that comes from each of those factors, and then we will put the multiplicity. So our first factor was negative x cubed, and that gave us an x-intercept of 0. Our second factor was x minus 3, which gave us an x-intercept of positive 3, and we had an x plus 2, which gave us an x-intercept of negative 2. And I forgot the squared on the x minus 3. Sorry about that. So how do we know the multiplicities? We look at the exponents. So for our x-intercept of 0, the exponent on the factor was a 3, so it has a multiplicity of 3. Our x-intercept of 3 came from the factor x minus 3, which was squared, so it has a multiplicity of 2. And negative 2 came from the factor x plus 2, which didn't have an exponent, but remember, when there's not an exponent written, there's an invisible 1 up there. So its multiplicity is 1. So that's how we determine our multiplicities of roots. All right. That is it for this video. We will pick up graphing in the next video. More graphing. Different than using our transformations, though.